It was 4 a.m. on November 25th, atop Hawaii's dormant Mauna Kea volcano, a site famed for its unparalleled night skies and some of the world's most advanced astronomical instruments. The crisp, cold air at that altitude carried a quiet serenity, punctuated only by the soft hum of computers and the occasional murmur of astronomers preparing for the night's observations. For most people, this was an hour for sleep, but for the team gathered here and the global audience watching online, it was the beginning of an extraordinary moment, the live observation of interstellar Comet 3 I/Atlas. The comet, traveling from beyond our solar system, had captured the attention of scientists worldwide for its unusual trajectory, composition, and the rare opportunity it presented to study material originating from another star system. The process to prepare the telescope was unusually smooth that morning, allowing the team to start observing sooner than expected, a small but welcome surprise in the unpredictable world of observational astronomy. On the main display in the control room, 3 I/Atlas appeared as a faint, diffuse blob drifting through a dense field of stars. To the untrained eye, it might have seemed insignificant, just another faint point of light in the vast canvas of the night sky. But for the astronomers and enthusiasts watching, this tiny speck represented an extraordinary window into the history of the universe. On a secondary monitor, the comet's light was spread into a spectrum, revealing a pattern of rainbow-colored lines, each corresponding to specific elements and compounds being released from its nucleus. Some lines shone brightly, indicating gases boiling off rapidly, while others were faint, hinting at more subtle chemical processes. This live spectroscopy allowed scientists to see, in real time, the physical and chemical processes unfolding on an object that had spent millions, possibly billions, of years traveling through interstellar space. Bryce Bolin, the principal investigator leading a study of 3 I/Atlas, greeted the global audience attending the session online. "This is some prime-time science happening in real time right now," he said, his excitement clear even through a webcam feed. The event was hosted by Shadow the Scientists, an organization that bridges the gap between professional astronomers and the public through live seminars, virtual tours, and interactive observation sessions. By connecting experts directly with non-experts, they made events like this accessible to anyone with an internet connection, allowing people across continents to share in the thrill of discovery. The observations were made using the Gemini North Telescope, one of the twin instruments of the International Gemini Observatory. Its counterpart in Chile, Gemini South, covers the southern skies, together providing nearly complete coverage of celestial events visible from Earth. Watching 3 I/Atlas in real time was akin to peering into a cosmic time capsule. Composed of ice, rock, and complex organic molecules, the comet was likely older than the Sun itself. Its journey across interstellar space had left it mostly intact, preserving clues about the conditions in a distant star system. This celestial visitor had wandered through the galaxy for untold millennia, finally passing through our solar system almost by chance, offering humanity a rare glimpse of material that formed far beyond the influence of our Sun. As it approached the inner solar system, the comet began to react to the Sun's heat, releasing gases and dust in spectacular jets. These emissions were captured on the telescope's sensitive instruments, revealing the comet's structure, composition, and activity in unprecedented detail. This was not the first encounter the Gemini Observatory had with 3 I/Atlas. In August, as the comet made its initial approach toward perihelion, the closest point to the Sun in its orbit, the Gemini South Telescope in Chile captured early images and spectra. At that stage, the comet's tail had just begun forming, a delicate stream of gas and dust illuminated by sunlight. The early data showed that unlike most comets in our solar system, which are dominated by water ice, 3 I/Atlas had jets rich in carbon dioxide and cyanogen. These differences hinted at its exotic origin, a body formed under conditions unlike anything seen in our planetary neighborhood. Scientists documented the emergence of its bright coma, the expanding cloud surrounding the nucleus, as well as the gradual growth of its tail, providing essential baseline measurements for subsequent observations. By late October, 3 I/Atlas had swept past perihelion at astonishing speeds, about 130,000 miles per hour, or 209,000 kilometers per hour. From Earth's perspective, it briefly disappeared behind the Sun, invisible to ground-based telescopes. During this period, spacecraft like the Mars Reconnaissance Orbiter and even the Perseverance rover were able to collect data, but terrestrial observers had to wait. When the comet re-emerged in November, the Northern Hemisphere had its first opportunity to observe the changes that had occurred since perihelion. The comet's brightness, spectral features, and tail structure had evolved, and astronomers were eager to compare these observations with the earlier datasets from Gemini South. Observers around the world, watching the live stream from their laptops, saw 3I/Atlas rise into the northern skies. Gemini North took over monitoring duties, capturing a clear view of the comet's reappearance. Brian Lameau, another observing scientist, explained, "This is our first observation from Gemini since the comet reappeared behind the Sun. We're under active observations right now, which is exactly what Shadow the Scientist is all about. This isn't just a show. We're actively analyzing and trying to understand the data. The comet is highly dynamic." Indeed, the comet exhibited unpredictable activity, with sudden increases in brightness, the emergence of new jets, and subtle shifts in the composition of gases being released. Before observations could begin in earnest, the telescope team conducted careful calibrations. Precision is critical in astronomy, especially when observing faint interstellar objects. Adjusting the telescope optics, fine-tuning detectors, and accounting for environmental factors such as wind, temperature, and atmospheric distortion ensured the accuracy of every measurement. These steps might appear mundane, but they are essential. Each photon of light captured from 3I/Atlas contained vital information about its chemical makeup, structure, and history. Without precise calibration, these data could be compromised, rendering the extraordinary opportunity to study an interstellar visitor far less valuable. As the comet came into focus, its complexity became apparent. Unlike native solar system comets, which tend to follow predictable patterns, 3I/Atlas surprised astronomers with its erratic behavior. Jets of gas erupted unpredictably, causing brief brightening events, and the spectral signatures indicated a range of materials being expelled from the nucleus. The comet's interior likely contained layers of differing compositions, a testament to its long, varied journey through interstellar space. Observing these features provided scientists with rare insights into the physical and chemical evolution of bodies from other star systems. For participants online, the live session was more than a scientific demonstration. It was an immersive experience in cutting-edge astronomy. Shadow the Scientists allowed viewers to ask questions, see high-resolution images, and hear commentary from experts who had spent years studying comets and interstellar phenomena. People from around the world shared in the excitement, watching in real time as scientists unlocked clues about an object that had traveled countless light years to briefly pass through our celestial neighborhood. Ultimately, observing 3I/Atlas was a glimpse into the vastness of our galaxy and the mysteries it holds. Each observation added to humanity's understanding of how planetary systems form, evolve, and disperse materials into interstellar space. Even after the comet continued on its journey beyond the reach of Earth-based telescopes, the data collected would continue to be analyzed, yielding insights for years to come. On that November morning, atop the quiet, wind-swept summit of Mauna Kea, science and wonder converged. The faint glow of the comet on computer screens, the careful adjustments of telescope instruments, and the excitement of astronomers and a global audience all combined to create a moment of shared cosmic discovery. 3I/Atlas, a lone traveler from another star system, had offered humanity a fleeting but profound connection to the universe, a reminder of the vast, ancient, and dynamic cosmos we are part of.